Today's lesson is on using exponents now and getting into multiplying and dividing powers. This actually goes pretty quickly. We just have to keep our eyes open to look for certain patterns, and then you will see what the rule ends up being. All right, now let's say I'm going to ask you to multiply these two powers of 6 together. 6 to the second power times 6 to the third power. Now, if I wanted to say evaluate, and you'd get all of this, and this is going to end up being a really, really large number. I'm just curious right now, or interested in thinking about what this means, and can you write this as a power of 6? 6 to the second power means 6 times 6. 6 to the third power means 6 times 6 times 6. So really, 6 to the second power times 6 to the third power, 1, 2, 3, 4, 5, really is the same as saying 6 to the fifth power. Now, yes, if I asked you to evaluate, this ends up being a really, really large number. But right now I'm more interested in looking at some sort of pattern you might be able to notice with the exponents when I have the same base. Let's see what happens if I just have variables. C to the second power times C to the fourth power. If I expanded this out, C to the second power means C times C, and C to the fourth power means C times C times C times C. Well, I'm not telling you what value to substitute in for C, and so there's really nothing we can do to so-called evaluate this. The only thing we can do is simply write this in a little neater fashion using exponents by saying this is the same as C to the sixth power. Look back at this one. 2, 3, 5, 2, 4, 6. If I had n to the fifth times n to the seventh. All right, now here comes the rather tedious process. If I wrote these all out in expanded form, so n to the fifth, there's 5 of them, n to the seventh, 1, 2, 3, 4, 5, 6, 7. I gotta count. 1, 2, 3, 4, 5, 6, 7. Yes. 1, 2, 3, 4, 5. Yes. All right. Well, certainly, if I have larger powers even than this, I am going to go crazy writing all of these factors down over and over and over again. And so the easier thing to do is simply write this as n to the 12th power. Much better than having to write that string of n's there. Here's an interesting one. 2 to the 5th times 2. Keep in mind what this means. 2 to the 5th, 1, 2, 3, 4, 5. Times this 2 gives me, let me get my pen back working again, times another 2. This is another 2. Kind of switch colors here a little bit. And notice now that if I go to simplify this, this actually becomes 2 to the 6th power. And what might be a little confusing or might be just a little bit something to watch out for is when this 2 is written here, even though it didn't have a power there, it really is a 2 to the 1st. And so when you line up or string out, expand out that multiplication, it's 2 to the 6th power. Well, hopefully by now you are starting to notice a pattern, because if I give you ones that get a little larger, and it's not like this is impossible, okay, 24 to the 4th power simply looks like that, and the next 24 to the 4th power simply looks like this. It gets to be tedious though, don't you think? And so I hope you're starting to notice this shortcut. And the shortcut for this one, where the final answer is 24 to the 8th power, actually becomes this, is that if you are multiplying powers with the same base, you simply add up the exponents. That's all you have to do. The key is that your base has to be the same. So as we look at this top one here, 4 to the second power times 4 to the fourth power, we just have to take those two exponents, add them together. I get 4 to the 6th power. X to the 2nd power times x to the 3rd power. The same base means add your exponents together. X to the 5th power. No. Now look at this one. I have x to the 5th times y to the 2nd. Because this is simply xxxxx, and this is yy. And you know what? These two guys have different bases, and there is nothing you can do. You simply have to leave it as is because your bases were different. All right. Now, actually, let's go back and look at this one. You know, there are times when you might have a negative exponent, and for that reason, we're going to apply the same exact rule. 41 to the 7 plus negative 3 power, and then simply combine those two numbers in the exponent to get 41 to the 4th. That's all you got to do. Now, what about dividing? Well, let's take a look at this first fraction, because fraction means divide. 5 to the 5th power is in the numerator. I'm going to write this out. 5 to the 5th power means you're multiplying 5 times itself 5 times. Here's 5 to the 3rd power in the denominator. Now, let's take a look at what happens when you have a fraction and you have the same number in the numerator as the denominator. They divide to give each other 1. They simplify to 1. 5 over 5 is 1. 5 over 5 is 1. Okay, well, I run out of things in the denominator, so up here I have 1 times 1 times 1, and which is 1, and then 5 times 5, or 5 to the 2nd power. In the denominator, all I have left is 1 times 1 times 1. This simplifies to 5 to the 2nd power. Let's look at another one. I don't like that example. Let's look at this. X to the 10th power over x to the 9th power. All right, x to the 10th power means x times itself 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In my denominator, I have x to the 9th power. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, I'm going to, even though these are variables, I'm going to use the same idea to say, well, an x in the numerator and an x in the denominator divide to be 1. Same thing here, same thing here, same thing here, and here. X over x is 1. 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 All of this is 1, and I am left with x on top and a 1 on the bottom. And this x is simply to the 1st power. Anything over 1, we can just write it as that, and you are done. Are you starting to notice a pattern? When you divide powers that have the same exact base, you simply take your exponents and subtract them. That means something like this, 9 to the 9th power over 9 to the 2nd power, gives me 9 to the 9 minus 2 power, which is 9 to the 7th. That's a huge number, by the way. I'm not asking you to expand that out and multiply. I just want you to leave it in exponent form and hopefully begin to notice that all you need to do is subtract the exponents. So your assignment is to look at these problems on this page. It goes very, very quickly. All right, very, very quickly. Good luck and work hard.